Alright, in this video we're going to be going over our naming of transition metals, polyatomics, going from our name to formula and formula to name. Alright, so this and everything will be on page 5 of the packet at the bottom. Alright, so if a metal has more than one charge, it requires a Roman numeral indicating which charge the metal has. So if the name has a Roman numeral in it, we're going to use that number as the charge of the metal when we cross, drop, and reduce. So these are going to be the 5 main Roman numerals that we'll use. So that I will be 1, 2 I's will be 2, 3 I's will be 3, the IV will be 4, and V will be 5. So we do have to remember those in order to use them as our charges. All right, let's go ahead and take a look at a few examples. So we started this and everything last class. So we're going to have our copper being our Cu. Now our charge of our copper will be 2 because of this Roman numeral right here. So plus 2 charge. And then we're going to have our fluoride being our fluorine. And then if we take a look on the periodic table, our fluorine will have a -1 charge. All right, so from here, we're able to cross our numbers. So what we get is our CuF2. And that will be our formula for copper to fluoride. All right, let's take a look at everything at our lead-4 nitride. So our lead being our Pb, we have that +4 charge. Our nitride being our nitrogen. Looking on the periodic table, our nitrogen will have a -3 charge. We'll go ahead, we're going to cross these down. So we are going to get our Pb3 N4. All right, our tin-3 bromide. So tin being our Sn, it will have this +3 charge. Our bromide being our bromine. Looking on the periodic table, our bromine does have a -1 charge. We'll go ahead, we will cross these down. So we get our SnBr3. And so that is going to how you're going to deal with creating the formula for a transition metal. So just again, remember those transition metals are going to be the ones in the middle. So copper, lead, tin, cobalt, iron, all of those are our transition metals. All right, and then again, there are the answers. All right, now next what we have to talk about is going to be our polyatomics. So our polyatomics are going to react and move as a group. Now the big thing with our polyatomics is that the names remain unchanged. Now our polyatomics will be found on the back of our periodic table. So we'll flip the periodic table over, and off to the left we will find a polyatomic list which has everything listed. All right, let's go ahead and take a look at a few examples. All right, so our first one is calcium nitrate. So our calcium will be our Ca, has that +2 charge. All right, and then looking at our nitrate, we'll find that on our list, and it will say our nitrate is going to be our NO3 with a -1 charge. From here, we'll go ahead and cross our charges. So our 2 will come over here, 1 will go to our calcium, and how we'll write this is our Ca. And now, because this 2 is going to be on the outside of our NO3, we are going to put our NO3 into parentheses, and then that 2 will be on the outside. And so this just makes sure that everything is separated, and this is telling us that we have 2 NO3s. All right, our ammonium chloride. All right, so ammonium is kind of special as it is the only positive polyatomic that we have. So ammonium is NH4 with a +1 charge, and then our chloride, being our chlorine, -1 charge. We'll go ahead, we'll cross those charges down. So what we get is NH4Cl. All right, and then number 3, our sodium hydroxide. Sodium being our Na, it has a +1 charge. Hydroxide, being a polyatomic, is our OH, and it has a -1 charge. We'll go ahead and cross these down. So we get our NaOH. So those are going to be our formulas for these different compounds. Now again, I cannot stress enough, where you find your polyatomics are on the back of the periodic table. So if we have carbon 8, phosphate, nitrite, all on the back of the periodic table. All right, our answers again. All right, and we'll move on. All right, last class we did our ionic naming steps, so we already know how to do these. Again, if you did not get those answers, here they are. All right, let's go ahead and look at our transition metals on page 7. Okay, so going from our formula to name is a little bit more difficult with our transition metals. So what we are going to do is that we are going to uncross the subscripts to find out what the correct charge is for the metal. After writing the name of the metal, we're going to write the charge using Roman numerals, put the Roman numeral in parentheses, and the nonmetal will have its ending changed to IDE. So let's take a look at a few examples. So our first one is our FeF3. All right, so first step is that we are going to uncross our charges. So what we get is Fe plus 3, fluorine minus 1. All right, so everything looks good. So what we're going to go ahead and do is that we're going to write the name. So our Fe being our iron. Now, because it is a transition metal, we'll take a look at the charge. So the charge of this is 3. And then our fluorine will become our fluoride. So we get iron 3 fluoride. All right, number 2. We're going to uncross these charges. So we get our Mn plus 1, Rs minus 1. Now, what you may notice is that our sulfur does not have a -1 charge. It is supposed to have a -2 charge. So what we have to do is that we're going to go ahead and multiply it by 2, but whatever we do to one element, we have to do to the other. So we're going to end up with our Mn plus 2, sulfur minus 2. And then we're able to go ahead and write the name. All right, our Mn being our manganese. It has that plus 2 charge, and then our sulfur becomes our sulfide. So manganese 2 sulfide. All right, number 3, we have our PbO2. All right, we'll go ahead and uncross these charges. So we're going to get our Pb plus 2 and our O minus 1. Now, if we take a look at the periodic table, we know that oxygen does not have a -1 charge. It has a -2 charge. So what we have to do is multiply our -1 by 2, but because what we do to one, we have to do the other, we'll multiply our plus 2 by 2 as well. So rewriting this, we're going to get our Pb plus 4, oxygen minus 2. Our charges look correct, so we're able to go ahead and write our name. So this will be our lead 4 oxide. So that will be our transition metals. All right, and then just looking at those answers again. All right, now going to our polyatomics, probably the easiest. Our polyatomics, they do not change their name. So what you see them as is what it is. And again, these are going to be found on the back of the periodic table. All right, let's go ahead and take a look at a few examples. So we have our CaClO3. All right, so our Ca will be our calcium. Okay, looking at our polyatomic list, we will find our ClO3, and we'll notice that our ClO3 is chlorate. So we get calcium chlorate. All right, number 2, our LiCN. All right, our Li being our lithium, our Cn being a polyatomic. So in this case, Cn is cyanide. So we're going to get lithium cyanide. All right, looking at number 3, our NH4Cl. All right, our NH4, our special polyatomic being positive, is our ammonium. And then our chlorine, our Cl, we'll change that to chloride. So our polyatomic in the front, we'll keep it the same. Because this is a normal nonmetal, we'll make sure it ends in IDE. All right, and that is going to finish up our naming. So we are going to be finished with this packet, and we are going to practice a little bit more, and then our test will be whenever we get back from Thanksgiving break.